Hello everyone, welcome to Maths and Science Intervention Club. My name is Mr. Nkona. Today we're going to be doing prime numbers. I'm decomposing a number into its prime factors. So we have what is called a prime number. Now a prime number, it is a number that has two factors which are one and itself. So it is a natural number that has two factors which are one and itself, right? Now let us look at the basic examples of the prime numbers that we have. So let us look at 2. I'm going to look for the numbers that can go into 2 without leaving a remainder. Those are 1 and 2. So when we look at this example, we can say that 2, it is a prime number because it has two factors, which is 1 and itself. Let us look at 3, numbers that can go into 3 without leaving a remainder. We are going to have 1 and 3. So these are the numbers that can go into 3 without leaving a remainder. Now let us look at 5, numbers that can go into 5 without leaving a remainder. It's 1 and 5. Therefore we can tell that these are prime numbers because they have two factors which are 1 and itself. Now after 5, now we have a list of prime numbers. Now the list of prime numbers, we are going to have a 2, a 3, a 5, a 7, an 11 and a 13. So these are the first 6 prime numbers, right? So now we have to know mostly, for example, 10 of the prime numbers. After 13, I'm going to have a 17. After 17, have a 19. After 19, a 23. After 23, I'm going to have a 29. So these are the first 10 examples of prime numbers. So we have what is called decomposing a number, right? For example, if it says decompose a number into its prime factors, right? So if for example, let us decompose 20. Decompose 20 into its prime factors. It means rewrite 20, but then the way of rewriting 20, rewrite it in a special way that you are going to represent 20 into its prime numbers. So when they say decompose 20 into its prime numbers, it means rewrite 20 in terms of its prime numbers. So the first thing that I'm supposed to do, I'm going to have a cross, right? Now from this cross here, I'm going to write a 20 on this side. Now I'm going to start with the first prime number, which is a 2. I'm going to ask myself, can a 2 go into 20 without leaving a remainder? If the answer is yes, it means I'm going to write a 2 here, right? Then I ask myself, how many times can a 2 go into a 20? It goes 10 times. I stick with the very same 2 up until it no longer works. Can a 2 go into 10 without leaving a remainder? If the answer is yes, I'm going to write the 2 here. Then I ask myself, how many times can a 2 go into 10? It goes 5 times. Now, can a 2 go into 5 without leaving a remainder? No. Therefore, I'm going to go to the second prime number, which is a 3. Can a 3 go into 5 without leaving a remainder? No. Therefore, I'm going to go to the next prime number after 3, which is a 5. Can a 5 go into 5 without leaving a remainder? Yes. Therefore, it means here I'm going to write a 5. Then I ask myself, how many times can a 5 go into a 5? It goes once. So all of these numbers that are here, right, I am going to rewrite them. It's going to be a 2 times a 2 times a 5. Now these numbers, they're equal to 20 because 2 times 2, that is a 4, and a 4 times 5, that is a 20. So now it means we have decomposed our 20 in terms of its prime numbers. It means 2 times 2 times 5, that is a 20. So when they say decompose 20 into its prime numbers, it means rewrite that particular number. For this particular case, it was a 20. Rewrite 20 in terms of its prime numbers. Now let us decompose another number. Now let us have decompose 18 into its prime factors, right? Decompose 18 into its prime factors. It means I am going to have a cross, whereby on that particular cross I am going to write an 18 this side. I'm going to start with the first prime number, which is a 2. Can a 2 go into 18 without leaving a remainder? Yes, it means here I'm going to write a 2. Then I ask myself, how many times can a 2 go into 18? It goes 9 times. Now, can a 2 go into 9 without leaving a remainder? No. It means I'm going to go to the next prime number, which is a 3. Can a 3 go into 9 without leaving a remainder? The answer is yes. It means here I'm going to write a 3. Then I ask myself, how many times can a 3 go into 9? It goes 3 times. Can a 3 go into 3 without leaving a remainder? Yes, it means I'm going to write the 3. How many times can a 3 go into a 3? It goes 1. It means all of these numbers here, I'm going to have a 2 times a 3 times a 3. The answer is going to give me what? It's going to give me 18, because 2 times 3, that is a 6. 6 times 3, that is going to be a 18, right? So it means the way of decomposing a number, in this case it was an 18, into its prime numbers is going to be a 2 times a 3 multiplied by a 3, right? Let us have another number. Decompose 144 into its prime factors, right? Decompose 144 into its prime factors. It means I'm going to have a cross here, right? Therefore, from that particular cross, I'm going to have 144 on this side. I'm going to start with the first prime number, which is a 2. Can a 2 go into 144 without leaving a remainder? Yes. It means I'm going to have a 2 here. How many times can a 2 go into 144? It goes 72 times, right? I stick with the very same 2 up until it no longer works. Can a 2 go into 72 without leaving a remainder? The answer is yes. It means I'm going to have a 2 this side. How many times can a 2 go into 72 without leaving a remainder? It goes 36 times, right? Therefore, I'm going to do the very same method. Can a 2 go into 36? Yes. I'm going to write the 2. How many times? It goes 18 times. Can a 2 go into 18? The answer is yes. How many times? It goes 9 times. Can a 2 go into 9 without leaving a remainder? The answer is no. It means I'm going to go to the next prime number, which is a 3. Can a 3 go into 9 without leaving a remainder? I'm going to have a 3. How many times? It goes 3 times. I'm going to have a 3, which goes into 3 only once. Now I'm going to have these numbers here, which is a 2 times a 2 times a 2 times a 2 times a 3 multiplied by 3, and my answer is going to be 144. So it means the decomposition of 144 into its prime numbers is the same as 2 times 2 times 2 times 2 times 3 multiplied by 3, right? So after we have what is called the highest common factor, right? We have what is called the highest common factor. Highest common factor. So we are going to use decomposition for us to find the highest common factor. Now we have the first one, the highest common factor. Let me just say I have 18 and 24. I'm looking for the highest common factor between 18 and 24. It means I'm going to write the numbers that can go into 18 without leaving a remainder. So for 18, I'm going to have a 1, a 2, a 3, I'm going to have a 6, I'm going to have a 9, and I'm also going to have an 18. So these are the numbers that can go into 18 without leaving a remainder, right? Therefore, I'm going to go to 24, numbers that can go into 24 without leaving a remainder. I'm going to have a 1, a 2, a 3, a 4, a 6, an 8, a 12, and a 24. So these are the numbers that can go into 24 without leaving a remainder. Now I'm going to look for the common numbers, right, between these particular factors. I'm going to see that 1, 2, 3, and 6. These are the numbers that are common within the factors of 18 and 24, right? So 1, 2, 3, and 6, these are the common numbers. But then I'm looking for the highest common factor. So these are the common factors or common numbers, right? So between those that are common, which one is bigger than those that are common? I'm going to see that 6, it is the one that is bigger than those that are common, meaning my highest common factor or my highest common number between 18 and 24, it is going to be what? It is going to be 6, because 6, it is a number that is bigger than those that are common. Although we have 1, 2, 3 that are common, but then we can see that 6, it is the one that is bigger than those that are common. Therefore, my highest common factor, it is going to become 6. Now, let us use decomposition and see if we are going to find this particular 6 as the highest common factor. I'm going to decompose 18 and 24 and see if I'm going to find the highest common factor, which is 6. Now, for me to decompose, as we already know, we are going to have a cross. Now from that particular cross here, I'm going to have an 18 this side and a 24 that side. I'm going to start with the 18. Numbers that can go into 18, the first prime number, it is a 2. Can a 2 go into 18 without having a remainder? Yes, it means I'm going to have a 2. How many times can it go? It goes 9 times. I'm going to have a 3. How many times can it go? It goes 3 times. I'm going to have a 3, which goes once, right? So it means 18, it is the same as a 2 times 3 times 3, right, in terms of its prime numbers. I'm going to go to the 24. I'm going to start with the 2. 2, can 2 go into 24? Yes, it goes 12 times. I'm going to have a 2. Can a 2 go into 12? Yes, it goes 6 times. Can a 2 go into 6? Yes. It goes 3 times. Can a 2 go into a 3? No, it means I'm going to go to the next prime number, which is a 3. Can a 3 go into a 3? Yes, it goes once. It means 24, it is the same as a 2 times a 2 times a 2 times a 3, right? So these are the decomposition of 18 and 24. Now, after doing that, I'm going to look for the prime numbers that are common. I'm going to see that this side I have a 2, I also have a 2 this side, right? And I'm also going to see that I have a 3 and I also have a 3 this side. So these are the prime numbers that are common. 1, 2 both sides and 1, 3 both sides. It means I'm going to drop those numbers that are common. It means here I'm going to have I drop those that are common here. After dropping those, I'm going to have a 2 times a 3, a 2 times a 3, because these are the numbers or prime numbers that are common both sides. And what is 2 times a 3? I'm going to have a 6. A 2 times a 3, I'm going to have a 6. So the multiplication of the numbers that are common within the prime numbers, that particular number, it is going to be your highest common factor. It means my highest common factor, when I use decomposition, it is going to become 6 between 18 and 24. Right, let us use decomposition to find the highest common factor between 72 and let me see, use decomposition to determine the highest common factor between 72 and 90, right? Between 72 and 90. So I'm going to use decomposition to find the highest common factor between 72 and 90. So it means I'm going to start with the 72, have a cross for 72, and I'm going to have a cross for my 90, right? After doing that, I'm going to have a 72 this side and 90 this side. I'm going to start with the 2. Can a 2 go into 72 without leaving a remainder? The answer is yes. It means I'm going to have a 2 which goes 36 times. I'm going to have a 2 which goes 18 times. I'm going to have a 2 which goes 9 times. I'm going to have a 3 which goes 3 times. I'm going to have a 3 which goes once. So that is the decomposition of 72. Now with the 90, I'm going to have a 2 which goes 45 times. I'm going to have a 3 which goes 15 times. I'm going to have a 3 which goes 5 times. I'm going to have a 5 which goes once. So that is the decomposition of 90, right? Therefore, it means 72, it is the same as a 2 times a 2 times a 2 times a 3 multiplied by another 3. Then for the 90, it is the same as a 2 times 3 times 3 times 5. So that is the decomposition of 90. So I'm going to look for numbers that are common both sides. I'm going to see I have a 2 this side, I have a 2 that side, right? I have a 3 this side, I also have a 3 that side, I have a 3 and a 3. So these are the only numbers that are common. 1, 2 and 2 of the 3s both sides. I do have 2 other 2s, but then here I don't have them. I have a 5, but then the other side I don't have a 5. So let me drop those numbers, right? After dropping those numbers, I'm going to have a 2 times a 3 times a 3. And what is 2 times 3 times 3? I'm going to have a 2 times 3, that is a 6, times 3, that is going to be an 80. Meaning my highest common factor between 72 and 90, it is going to become 18 by using decomposition to find that particular highest common factor. Right, thank you. I hope you enjoyed this lesson. Please don't forget to like, comment, share, and subscribe. Thank you.